Okay, our third property of the day, also impacted by intermolecular forces, it's viscosity. Viscosity may be something that you've heard of. You've heard of like viscous liquids. What do you think of? I think of like maple syrup. I think of like motor oil. Um, any liquid that just doesn't really flow very well. In fact, if you look up the definition of viscosity, viscosity is a resistance to flow. Okay, so take a look at the viscosity values in the table for some alkane molecules. It doesn't really matter what those units mean in this case. We just see that they're getting bigger. The numbers are getting bigger, and so the bigger the alkane is, the higher its viscosity. Well, look at those formulas. Those formulas for those alkanes are increasing the length of the straight chain alkane. And you know that alkanes are nonpolar. You know that they only have London dispersion forces. And you also know that London dispersion forces increase when we have heavier molecules or molecules with more electrons. So in our list of five molecules there, it's the heaviest one that is the most viscous, decane. And it's the lightest one, hexane, that is the least viscous. So the stronger the intermolecular forces are, the higher the viscosity is. Now, let's talk about the molecule that is at the bottom called glycerol. Now, it's not nearly as long of a chain as any of those alkanes above it. It's only got 3 carbons in it. But look down at the bottom. You see those OHs, and that should sound off alarm bells in your head, because anytime you see an H that's attached to an O, you know that that particular um, uh, atom, that particular hydrogen atom, um, is capable of making hydrogen bonds with other molecules. So, in the case of glycerol, it's one of the most viscous substances you'll ever see. Why is that? Well, it's viscous because not only can it make a hydrogen bond, it can make 3 of them, right? There are 3 OHs present. So I guess the question becomes, why does having strong intermolecular forces, why does that make a substance more viscous? Well, I always think of intermolecular forces as stickiness, right? So if a molecule is really sticky, it's hard for it to move past its nearest neighbor molecules. And in addition, if you look at those straight chain alkanes, they're almost like shoelaces. They can get tangled up with one another, and the more tangled up they get, the stickier things get and the harder it is for them to flow. Just like before, I'm going to show you another video that shows viscosity in action. So stick around for that, and then we will meet once again.